Yes, I thought I
complicated
understood.
about.
You're telling me
Yep.
something now that you're telling me that von Neumann didn't think he understood it. Well, I'm surprised. I thought he understood it. I think I understand it.
I don't think he understands entropy. Welcome to the Bottom Turtle channel. I'm theoretical physicist Dr. Shannon Ray, and in this video, I'm going to explain the true nature of entropy that no other scientist will tell you. And it's not that no other scientist will tell you because there's some sort of grand conspiracy to keep you outside of the know like this guy would have you believe. Instead, it's because I don't think other scientists truly understand the nature of entropy. And to demonstrate what I mean, I'm going to react to a conversation between Leonard Susskind and Jaimungal on the Theories of Everything podcast, where Kurt points out to Leonard that Jon von Neumann believed that no one really understood what entropy was. And Leonard seemed to be shocked by this and proceeded to give his explanation of entropy, which, in my opinion, is missing the true nature of entropy that seems to elude other scientists. So wait until the end of the reaction video to find out what this true nature of entropy is. And if you want to get subsequent videos in which I go into a deeper dive of what the true implications of this meaning of entropy is, then make sure and subscribe to the channel. With that, let's get into it.
You mentioned Tuft, you mentioned entropy. So there are two questions I have, and you can choose to answer both or just one of them.
Yep.
I believe it was Wheeler, or no, I believe it was von Neumann, who said no one understands entropy. Do you still think that's true? So that's one question about entropy you could tackle if you like.
I don't know. Did von Neumann say that?
He said that if you don't know what you're talking about, you can call whatever you're talking about some adjective then entropy, like von Neumann entropy or Shannon entropy, because no one knows what entropy is anyhow.
Or Boltzmann entropy.
Yeah. So there's that. And then there's also, well, how about, what do you make of that? Do you feel like that's overrated? Entropy is understood?
Yeah, I think look, nothing in physics tends to be ultimately understood.
Now, I know he may think that people understand entropy, but I don't think people understand entropy. And the point to this video is I want to give you the insight that I have in entropy that no one else has. So my answer is no. Physicists do not understand entropy, and I think I'm the only physicist that really actually understands what entropy is.
We always have developing understandings of almost everything. So to say that something is understood, if you mean by that a final, complete understanding that will never change, I think almost nothing in physics is like that. But if you mean there's a working consensus on how to use it, forget the word understanding for a minute. How to use it, how to make predictions with it, how to
yeah. And see, this is another problem I have, is that he says when it comes to our understanding on how to use it, there's a consensus on that, and to forget understanding. And from what I can tell in physics is that this is a predominant mode of thinking, where the idea is shut up and calculate. Like, one of the insults that physicists tell each other is that you're being a philosopher. So if you overly think too much about what something is or what something means, then you usually get criticized for it. And this is the exact type of mentality that he's expressing here. And I think it's exactly why most physicists do not understand entropy, and they miss a crucial aspect of entropy that actually opens it up and is, I think, revolutionary and groundbreaking. And so yeah, so this is a problem in his perspective. Simply understanding how to use it to do calculations and make predictions does not mean you understand it. It's not sufficient.
I think there's consensus about what entropy is.
What could be more
Yes, I thought I understood.
About,
you're telling me something now that you're telling me that von Neumann didn't think he understood it. Well, I'm surprised. I thought he understood it. I think I understand it. But, will it change? Will it be an evolution of our ideas of entropy? I think probably yes.
Yeah. See, that's the thing. I don't think he fully understands it. Like, I'm not trying to be like a dismissive jerk or anything like that, but I don't think he understands it, and I don't think almost any physicist understands it. And when he says that it will evolve and our understanding will evolve, I completely agree with that. And I do think that I'm the one that has a perspective that will evolve and change entropy in a revolutionary way. And I'm shocked that no one else has put together this element of entropy before.
The definition of entropy has to do with counting microstates. However, there are other ways of viewing what entropy is. How do you view what entropy is?
It's one way of thinking about it. The other way I like to think about it is it's hidden information. That information about a system, detailed information about a system.
So his answer that it's hidden information is actually really spot on. So that is very close to having a complete understanding of entropy. So in my understanding of entropy, there's two things that are very important. The first one is that entropy is ignorance. So hidden information, ignorance, whatever you want to call it, entropy is ignorance. That's the first insight you must have. But the second insight that I have that no one else has is the one that makes most physicists' understanding of entropy incomplete.
Which is for one reason or another hidden from you. Now, why would it be hidden? In the case of a gas of particles, what is the total amount of information that you need to be able to describe? I'm talking about classical particles now. What do you need to know about all of those particles to be able to predict their future? You need to know the position and the velocity of every particle. That's obviously not feasible. Why? Because there are just too many particles and they're too small.
You see, and in this explanation where he says you need to know all the position and velocities or the position momentum, and that's the reason why we have to invoke entropy, this is precisely the thing that's missing from people's understanding, because what he's describing is subjective ignorance, subjective uncertainty. He's saying there are simply too many particles, so because there are so many, there's no way we can know the position and momentum of all of them. Therefore, we have to use information that we have access to, and this is the macro data. So this is like the average pressure or the temperature or the number of particles, something like that. You have to use some other information that is lower resolution, that doesn't have the precise position momentum of every single particle, because that's just impossible. But that is almost asserting that entropy is solely a result of subjective ignorance. But my understanding of entropy actually adds an extra element that makes it a much more broad thing that goes beyond just mere subjective ignorance.
Too many and too small. So that information is hidden from you. It's hidden from you just by the fact that there are so many of them and they're so small, and no feasible experiment can determine the position and velocity of every particle. So all of that information is hidden. It could be hidden for other reasons. It could be in some other room where you don't even know where it is. But hidden information is what's called entropy. That's one view of entropy. The other is that it's counting microstates. Now, it's sort of the same thing. The microstates mean...
Now here he says another that it's counting microstates. But that, again, that is in the context of something like a Boltzmann entropy. But what about Shannon entropy? The overarching concept or essence of entropy that will be consistent for any definition of entropy you find is ignorance. Entropy is ignorance or uncertainty, however you want to say it, ignorance or uncertainty, but that's the element, that's the important thing, that it will be consistent for any entropy measure that you ever use. It will be measuring some degree of uncertainty or ignorance.
States mean, well, what is a microstate? A microstate, in the case that I described, is the position and velocity of every particle.
See, and that definition of microstate he just used is for a specific example of a gas in a container. But in general, microstates are higher resolution data that are consistent with some lower resolution data. So typically with a microstate, you have some sort of macro data, and then there are a bunch of microstates that are consistent with that macro data. So that's the whole point. It's a many to one mapping. You have one, which is the macro data, and then you have many, which are the microstates. And each one of these microstates maps back to the macro data. So in other words, if I only have the information of the macro data, I don't know which microstate is responsible for that. And that's where the ignorance comes from.
You count the number of microstates that you can't distinguish because there are too many particles, too small. You take all of those microstates.
And see, again, because he's talking about too many particles or too small, he's confining the meaning of entropy. He's confining it. You don't need to worry about number of particles or whatever. The only thing you need to worry about is that there's a macro state and a bunch of microstates, many to one mapping. That's it. That's where the ignorance comes from. That's what entropy is counting. So this whole thing about particles, like, it doesn't have to be particles. It could be anything that follows this. This is the thing that, this is what people don't understand. And it's the essence of that, of the many to one mapping, is the thing that no other physicist, as far as I can tell, seems to really grasp the true essence of entropy.
Which you cannot distinguish from one another, and take the logarithm of that number, and that's the entropy. So ultimately, it's hidden information that you don't have the capacity to distinguish for one reason or another. As I said, another reason you might not be able to distinguish it is because they're hidden behind the horizon of a black hole.
Okay. So, I mean, that's the video right there. So, so in other words, if you listen to Leonard Susskind, everything he's saying about entropy is correct. And I would say that his understanding of entropy is consistent with most physicists' understanding. Like, this is what an average physicist or chemist or anyone would tell you if it has to do with microstates and it has to do with, you know, there's too many particles so you can't track all of it. But that's not the essence. The essence is many to one mapping. And what that produces is, and this is the thing that is the insight that I have that no one else has, is that that produces symmetry. So to understand entropy, what you need to understand is, 1, entropy is ignorance, and 2, ignorance implies symmetry. That's the thing. And without that, without this two combo of understanding that entropy is ignorance, ignorance implies symmetry, but you also have that symmetry implies ignorance. So you also have, whenever there's symmetry, there is entropy. And another way to state this is that if there is information, then there is a broken symmetry. The reason why this is so profound is any physicist knows that that almost the entirety of the foundations of physics are built on the concept of symmetry, and that we build all of our theories off of it. And so it's this relationship between symmetry and entropy that no other physicist seems to have or understand. And I have used this understanding that no one else has to do a calculation where I discovered a new definition of entropy in quantum physics. And this definition is tied to so much of reality you can't even begin to comprehend it. It's tied to quantum entanglement. It's tied to the concept of the arrow of time. It's tied to, I would actually say a multiverse understanding of reality. I think it gives a clear entropic understanding of quantum physics and what quantum states and quantum physics is. The depth of perception that's allowed once you connect symmetry to entropy is insanely profound.